they've given us a and b, and we've had to find c. Now let's take a look at whenever we are given like b and c and we have to solve for a. So I'll work it out over here. It says find the unknown length a in simplest form. Oh, since it says simplest form, we're going to have to use our list of perfect squares, so you might want to get that out. We have a squared plus b squared equal to c squared. A squared we don't know, that's unknown. B squared is 10. It's going to be 10 squared. C squared is 12, so it's 12 squared. So a squared plus 100, because it's 10 squared. 12 squared is 144. Now I'm trying to get a by itself, just like we've been solving all year. First thing you have to do is get rid of 100. So I'm going to subtract that. 144 minus 100 is 44. Now they want me to, I want to get a by itself, so I take the square root of both sides. That cancels out. I get a equals the square root of 44. Now it doesn't want me to round it. Notice it doesn't say round to the nearest foot or nearest tenth or anything. It wants me to write it in simplest form. So that's when I use my list of perfect squares that we have written down. And we only have to go up to 44, so I'm going to stop here. Does 36 divide evenly into it? No. 44 divided by 25, decimal. 44 divided by 16 is a decimal. 44 divided by 9 is a decimal. 44 divided by 4 works out. I can break this into the square root of 4 times 11. They each get their own little house. The square root of 4 cancels. It's a perfect square, which is 2. And that is my final answer, 2 square roots of 11. All right, let's try a couple more. We're almost done. Here they give us some sides. A squared plus b squared equals c squared. A squared is 20 squared. B squared, I don't know. And c squared is 25 squared. 20 squared is 400 plus b squared equals 625. I'm going to subtract 400 on both sides. I get b squared equals 225. I take the square root of both sides. Square root and square can cancel out. I get b equals 15. And that's my answer. It fits. And that's another thing. You can always go back and see, does your answer make sense? If this is 15, yeah, that's 20, that's 25. It all makes sense. It's logical. It's not like I got 100 or something. All right. A squared plus b squared equals c squared. A squared is 10. 10 squared plus 24 squared equals c squared. 10 squared is 100. 24 squared is 576. So I add them both together. I'm going to get 676. Now I'm going to take the square root of both sides to find out what c is. Those are going to cancel out. I get c equal to square root of 676 is 26. So that's another perfect square. That one, again, it doesn't say here whether to round it or not, but we're going to find it in simplest form. If it doesn't say round it, use it in simplest form like we did here. 676 is way off the charts, so always first check and see if it is a perfect square, and if not, you can start dividing using our numbers, our perfect squares. Alright, last one. A squared plus b squared equals c squared. I'm going to go ahead. A squared plus 12 squared is equal to 14 squared. A squared plus 144 is going to be equal to 196. I subtract 144 on both sides. A squared is equal to 52. I'm going to take the square root of both sides. Those cancel out. Now I have a equals the square root of 52. Square root of 52 is not a perfect square, so I'm going to go ahead and start dividing. 52 divided by 49 is a decimal. Divided by 36 is a decimal. Divided by 25 is a decimal. Divided by 16 is a decimal. 54 divided by 9, or I'm sorry, 52. Maybe, let's see if it's not going to be 2, or not going to be 9. And 52 divided by 4, that one works. So I can break this into square root of 4 times 13. They each get their own little house. 4 gets a house, 13 gets a house. Square root of 4 is 2, square root of 13 stays the way it is. Okay? Again, if it says simplify it, then that's whenever you break it apart like this. If it just says round it, that's when you can use your calculator. Last little bit, example 3, it says determine whether the triangle with the given side lengths is a right triangle. So it's almost like if you had 3 pieces of metal, you were building something, and you wanted to know, can I make a right triangle with this? Because you had to build a right triangle for what it was that you were working on. You can use the Pythagorean theorem to work kind of almost backwards, and you can say, all right, do these 3 sides make a right triangle? So here they have them labeled A, B, C. If they don't have them labeled, your largest one's always going to be C. So a squared is going to be 3 squared plus 5 squared equal to 7 squared. 3 squared is 9. We're looking to see if that's true or not. 3 squared is 9. 5 squared is 25. 7 squared is 49. 9 plus 25 is 34. 34 does not equal 49. So no, this does not make a right angle. Determine whether it can make a right triangle. No, no right triangle. All right, let's try letter B. A squared plus B squared equals C squared. A squared is going to be 15 squared plus 8 squared equals 17 squared. 15 squared is 225. 8 squared is 64. And 17 squared is 289. 225 plus 64 is 289. So 289 equals 289. Yes, you can make a right angle, a right triangle with these sides. So that would work. Alrighty, great job. It's my favorite theorem and I hope you love it too.